Welcome to the Statistics Arcade. Prepare to level up your stats. I created these videos to show you how we can better understand statistics through video games. This video will cover descriptive statistics, including histograms, mean, median, and mode. I hope you enjoy. In the Statistics Arcade, I have a variety of videos. This particular video is called a deeper dive. I will spend more time covering statistical topics relative to some of my shorter videos. In this deeper dive, we take a closer look at visual representations of descriptive statistics, in particular histograms and bar graphs. We will then explore the measures of centrality, including the mean, median, and mode. My deeper dive videos simulate my traditional statistics lectures, so make sure to watch this video when you have the time and the headspace. Descriptive statistics make more sense if we can think about them in the context of a real-world story or event that we can relate to. So, imagine that the Statistics Arcade is holding a Galaga contest. The first 100 players to show up to the event will be competing for the grand prize, a brand new Atari 2600. Each player has one game to earn as many Galaga points as they can. Those Galaga scores are recorded. Since we don't have an actual Statistics Arcade, I made these scores up using a statistical software program. I asked the program to randomly generate a Galaga score for each player, and I set the possible range for 2,000 points at the low end and 15,000 points at the high end. Based on this imaginary set of Galaga scores, I then created a visual representation called a histogram. A histogram is a visual display of data. Notice that the horizontal axis, called Galaga score, moves from left to right. The farther to the right you go, the higher the score gets up to a maximum of about 15,000 points. The vertical axis is a frequency count of the number of players who achieved a particular score. Scores are categorized according to bins. Each of the bars represents a range of about 1,000 points. We can see that 5 players scored around 2,500 to 3,500 points. Another 5 players scored around 14,000 to 15,000 points. The most common scores were around 7,000 to 8,000 points. I want to take a moment here to talk a bit more about graphical displays for descriptive statistics. On the left is a bar graph. Notice the gaps between the bars. That's because the data represents different groups. Imagine that the vertical axis is the amount of money spent per year on video games. The bars represent the average amount spent in 5 different countries. On the right is a histogram. Notice no gaps between the bars. That's because the data represents a number range from low to high, like Galaga scores. The bars represent the frequency of observations for a particular bin of scores along that continuum. This image is important because we are now moving from histograms to measures of centrality. Measures of centrality are numbers that represent how data clump together in a distribution. The 3 measures are the mean, median, and mode. Notice that in a symmetrical distribution, the mean, median, and mode all line up. When the distribution is not symmetrical, it is skewed, and the mean, median, and mode diverge from one another. You can think about the measures of centrality as measuring how data clump together in a distribution. The mean is the average score. The median is the middle score. The mode is the most common score. The mean is what most folks are familiar with. It's the average score. If you sum up all of the data points and then divide by the number of data points, you get the mean. So, if we summed up all Galaga scores for all 100 players in our imaginary data set, they earned 858,359 points. If we divide that by the number of players, we get a mean score of 8,583.59. So, the average Galaga player earned about 8,600 points during their game. The median is the middle score in a distribution. You can find the median score by sorting all of the scores from lowest to highest and finding the middle score. We can see that player number 70 had the lowest Galaga score of 2,140 points. Our Atari 2600 winner had the highest score of 14,867 points. The middle score in our sample is the average of players 83 and 63, which turns out to be 8,569.5. That's pretty close to the mean score of 8,583.59. Why would we ever want to use the median score when we have the mean? The mean is sensitive to extreme scores, but the median is not. If we replace the highest Galaga score in our sample with a world record score, the mean would drastically change from about 8,500 points to well over 100,000 points. The median is unchanged because it is the middle score, so it's not influenced by extreme scores. The third and probably least useful measure of centrality is the mode. The mode is the most common score, and it is easy to find in a histogram. It's represented by the tallest bar. In our sample, the mode is right around 8,000 points. Symmetrical distributions usually only have one mode, but some distributions can have multiple modes, which don't have to be near the center, and that makes the mode one of the more confusing measures of centrality. Remember how, in a symmetrical distribution, the mean, median, and mode all line up? We can see that in our imaginary data set, the mean, median, and mode are all close to 8,000 Galaga points. That wraps up our deeper dive on measures of centrality. I hope our video game example has helped you better understand visual displays like a histogram and measures of centrality like the mean, median, and mode. Thanks for joining me. If you enjoyed this video, please like this video and subscribe. Next time, we'll cover Descriptive Statistics Part 2, Measures of Dispersion. See you next time.